Okay, so these are basically the distances. Okay, so obviously from 0 to 2, you're going backward. So if this is in miles per hour, we have to make sure, you guys, that we, right here where it says include units in your analysis, you need to make sure that you put miles here. Okay, that's real important for this whole section, is that we put labels on things so that it gives it a context. All right, so this is saying that in the first 2 hours, you went backward 5 1/3 miles. Miles per hour, hours, yes. And right here in the next, I'm just trying to see, yep. In the next 3 hours during this time, you went to the right 27 miles. Wow, you're not going very fast. I'm trying to think, is this seconds? No, it's not minutes. It is. All right. This one right here says that during this whole time, if you take a look at these two right there, you've gone a net distance of 21 2/3 miles to the right. All right. And then you, the total distance that your car has traveled is 32 1/3 miles. If I had to draw a picture, it would be, it says right here, now suppose the car started 4 miles away from a checkpoint on the positive side initially. Where's the car in relation to the checkpoint at t = 5? Well, whenever you start initially at a point, and this is 4 miles to the right, normally without this 4 miles, this is like your 0. That's your starting point. What happened was you went to the left 5 1/3, then you turned around and you went to the right 27 miles to end up at 21 2/3. That's kind of what happened here. That's how you got 32 1/3. They're saying in this little thing right here, now that if this is 0, that you're going to start right here at 4. Which means, okay, now you are going to go back 5 1/3. Then again, you're going to go forward 27 miles. And they want to know, where do you end up? Well, all you need to do is with this particular thing right here, is you just need to add 4. That's where you end up. Okay, does that make sense? My little diagram picture.
Wait, I thought the car started at 4 miles away from the checkpoint, not on the checkpoint.
No, it starts right here. This is the first situation. This is number 1. This is this stuff right here. This is right here where it started 4 miles away. That's the second situation, where it's starting right here. This is where it's starting at 4 miles. Goes back 5 1/3. So basically you end up at a -1 1/3. Then you go 27 miles this way. Okay, so if you go 27 miles this way, you end up at 25 2/3, which is basically 21 2/3 plus 4. Make sense? Okay. Like I said, I feel better when I draw a picture and have a visual. All right. So these are the things that they're going to ask you to do. All right. Okay. Now, basically, this is motion. This is the summary of the rules right here. Displacement, okay? You've kind of heard of displacement when you talk about water in a beaker. If you have some water in a beaker and you're at, I don't know, 5 milliliters or whatever, and then you put an object in there and it goes to 7 milliliters, you know that the object took, it was displaced by 2. That's the net change. Distance traveled is the gross distance. Basically, right here, it's the absolute value, okay? It's taking all those negatives and making it the same. Now, right here, this is where you have a position. This is the kind of like the starting point, and then you have to add it. That is what we did right here. This was our starting point, and we added it to this net integral. to get where you end up. This down here is like absolute value, except it reversed these right here. So instead of making, see how this ended up being negative? We reversed the limits, so this ended up being a positive 5 1/3, and then this was your, this right here from 2 to 5 was your 27 to get your total of 32 1/3. That's what happened there. All right. Now, here's an actual AP problem that you might have. Okay, this was on the 2009 one. You can use a calculator, and they gave you this lovely graph. Karen is riding her bicycle along a straight road from home to school, starting at home at time equals 0. Okay, so this is home. She arrives at school in 12 minutes. During the time interval from 0 to 12, this is her riding her bike. Her velocity is in miles per minute, modeled by the piecewise linear function whose graph is shown above. Nice geometric shapes in there. That's kind of nice. Find the acceleration of Karen's bicycle at time equals 7.5 minutes. Indicate units of measure. Okay. At 7.5, I go up here. Okay. We're looking for acceleration. This is a velocity graph. What's the relationship between acceleration and velocity? Yep, it is the derivative, okay? So what does that mean when we're looking at a line? What are we looking for? The what? The slope. Great. Now, just look at this line. Does it have positive or negative slope? Okay, it has negative slope. Great. And what is its slope? -1. Okay, so acceleration equals -1, but now we have to do the units. Okay, this is minutes. This is, what do we have? Miles, straight road, minutes, miles per minute. Miles per minute. Okay, so the derivative of this is going to be miles per minute squared. Okay, acceleration is something squared. All right, does that make sense, you guys? Okay. All right, using correct units, explain the meaning from 0 to 12 of the absolute value of velocity in terms of Karen's trip. Okay, all we have to do is explain this. What does this mean from 0 to 12, the absolute value of velocity? What did we just talk about right up here? When you take the absolute value, what does it mean? It's the what? They say gross distance traveled. What do we typically say? Total. Okay? So this, the integral from 0 to 12 of the absolute value of t is the total distance and then in terms of Karen's trip, so it's the total distance in what? Miles. Karen traveled in 12 minutes. Okay, I indicated that these are the minutes, and this is total distance that she traveled, and she traveled them in miles. Then they ask us to actually find the value of this. Okay, so the value of this, how do you find the integral? The integral is the area between what? The curve and the what? X-axis? Okay, just use geometry. What is this? This is a triangle. 1/2 base times height. It is 0.2. So keep in mind it's 0.2. So it's 2 times, and then this is probably why you're allowed to go ahead and use a calculator. So in that first part there, what do we have? We have 0.5, 1/2 times base times the height, and we get 0.2. Okay, so we're going to have right here, and I mean, go ahead and write on this if you want. You can say, all right, that's 0.2. This is the same shape, so this is 0.2. We're doing absolute value, so we're not going to worry about the fact that it's negative. This is nothing. We can divide it up. We can have this little piece right there. So we're going to say 1/2 times 1 times, and the height of this is 0.3, and we get 0.15. So this part is 0.15. Then we can do this. That's easy. That's 3. If you want, how do you want to do it? You want to cut it like this? That's 2. This little tiny piece in there is 0.1, so 0.05. That's that little piece. Here, we've got 1, 2, 3, 4. You've got 6, and then you've got this piece down here, which is 1 times, this is 0.1. Okay, so then add them all up. 0.2 plus 0.2 plus 0.15. Okay, add them all up. $11.7. miles. Oh, I did that wrong. You guys, this is not 3. It's 1 times, it's 0.3. And this is 0.2, and this is 0.6. Sorry. I thought she went kind of far in 12 minutes. Yeah. Okay. Well, yeah, she was cruising right along. All right, that's right. I'm just going to, yeah.
So for that 1.17? No. Nope, forget I said that.
Let's see here. Do I have them all? Yeah, 0.3. What else was I supposed to put a point in front of? The 6.
Yeah.
And that's it. 1.8. Yeah, that makes a little more sense.
She's still going pretty hard.
Yep. Okay. Shortly after leaving home, Kieran realizes she left her calculus homework at home and returns to get it. At what time does she turn around and go back home? What time is that? Where does she turn around, guys, and go back home?
At 2?
Yes. So in C, we kind of say at 2 minutes. That would be me this morning, who started off and then had to turn around and go back home. Yes, at 2 minutes, Karen turned around. Does it say to justify? Oh, give reasons for your answer. What could we say to know that this is where she turned around? That's correct, yes. The velocity graph changes from positive to negative at 2 minutes. Oh, now Larry's riding his bike too, guys. Larry rides, look at his formula. Larry also rides his bicycle along a straight road from home to school in 12 minutes. His velocity is modeled by this function. Okay? He is not quite the linear rider that Karen is. This is in miles per minute for 0 to 12 minutes. Who lives closer to the school, Karen or Larry? Show your work that leads to your answer. All right. How far away does Karen live from the school?
Let's just guess right now. I guess Larry.
I know, but how far away does Karen live from the school?
1.18 miles?
No.
No, less than that.
No, think about it.
1.6.
Oh,
Yes, 1.6. Remember, she turned around and had to go back.
Yeah.
So lives 1.6 miles from the school. And how are we going to figure out how far Larry lives? We're going to integrate this? Okay, now, but here's the thing, you guys. When we integrate this function, we have to see if it goes below the x-axis. Because if it does, for some reason the guy turned around and went back for something. I don't know, maybe he dropped his calculus homework and had to go back for it. So what you always want to do is you want to graph this to see what it looks like. Okay? So when we graph this, here, let's check this out. Okay? Go into there. Again, it's a trig function. Please make sure that you are in radian mode. All right? And we are going to graph. Here we go. Sine. And then we've got okay. Okay, what we want to do now is we want to see what it looks like, but we have to make sure that our x value is from 0 to 12, okay? So just what I would do right now is definitely just, how high is this sine graph going to go, guys? What's its amplitude? What's the number in front of it? Pi over 15. Okay, so it's not going to go very high on the y-axis, okay? So 3 divided by 15 approximately, I mean, that's 1/5. That's like 0.2. So what you can do is when we go to our window, your y min and max can be 0.5 and a negative, oops, wrong way. 0.5 and a negative 0.5. It's not going to go any higher than that. Our t, we want to go from 0 to 12. Okay? So so take a look at your function sometimes to see, you know, what you're going to need to do. Okay. So now we're going to graph this. And this is Larry going to school. Oh, Larry never went backward, did he? He went the whole time. So this is nice in the fact that how are we going to find the area under that curve? What do we need to do? How do you find area under a curve, guys? Just integrate it? Did you? Oh. Okay. So we're just going to integrate this function. It wouldn't hurt, you guys, if you were taking the AP test, it would not hurt in the least bit for you to graph the function for, you know, the people to see that you understood, you know, what in the world you were doing. Okay? I mean, you could just draw this and that'd be fine. All right. So now, because I've already typed the function into y1, when I go to my home screen and I'm going to do this integral, I'm going to go 0 to 12. I don't want to retype the whole function, you guys, because that just takes forever. It's already in y1, so I'm going to do alpha trace. There's y1, and just put it in and do dx. And there it is, 1.6. They live exactly the same distance from school. Maybe their brother and sister. Yep.
Wait, how do you put the y1?
I did alpha trace, and then they come right there. You can get to it by going to VARs and all that other stuff, but that could be same apartment complex. They live, oops, and I should probably put miles there. They live the same distance away. Okay? All righty. Okay, let's take a little break right now, and we'll come back.